up the topic questions, set 1 for Unit 1. We're going to do number 3 and 4. If you recall from number 2, we were investigating this scenario with these two experiments. We had these two graphs. In experiment 1, what's the speed of the ball the instant it makes contact with the ground? So there's a bunch of ways you can do this. You can pull, the best way is to kind of pull stuff off this graph. And if you know that the change in y, right, when it gets to the ground is going to be 1.5 minus, should be 0 minus 1.5, which is negative 1.5 meters. We're going to have a time here. And we want to know if the initial velocity is 0. We've got the final velocity, which is what we're looking for. And we know, because it's in free fall, that acceleration is negative 9.8 meters per second squared. Now, you might not know this yet, because we may not have done this yet in class. This is a constant for any freely falling object. Now, why didn't I use time? Well, the problem is that I don't know when it gets to 0. You see that? Like, I could guess, but that's really not the best thing to do, right? Is to like kind of extrapolate. So you want to know things, you want to use things that are given. But let's say, what if you did guess? What if you said, okay, that looks like about 0.55. So let's do it both ways and see which one, how they come out. So the equation that we use, oops, wrong one. The equation that we're going to use for this is we're going to use v final squared equals v initial squared plus 2a delta d. So we're going to have the final velocity, which is what we're looking for. The initial velocity is 0. Acceleration is negative 9.8. This is negative 1.5. So we've got 2 times 9.8 times 1.5. I left out the negatives because they cancel. And then take the square root. And you get 5.4 meters per second. So there we go. Done. Now, what if we used the time? So let's check that method as well. So to find final velocity, and leaving out acceleration, right? This is going to be using this equation. Now, this is an equation that's not on your equation sheet, but look where it comes from. This is V average equals delta D over delta T, where V average is 1/2 V initial plus V final. That's what an average is. So you can, kind of put those together and get that. So let's keep going with this. This is negative 1.5 equals 1/2 V initial plus V final, and we're going to estimate that as 0.55 seconds. So I've got 1.5 times 2, right, or divided by half, divided by 0.55, and that gives us 5.45 meters per second as V final, which would give you the same thing. These are spread far enough apart to be able to make a decent estimate. Either way, you're comfortable. A student is provided with a battery-powered toy car that the manufacturer claims will always operate at a constant speed. The student must design an experiment in order to test the validity of the claim. Which of the following measurement tools can the student use to test the validity of the claim? So we're looking at this question. Does it always operate at a constant speed? So in order to do that, think about it. What do you need to know? You need to know the speed, not just the beginning and the end, but for the entire time in between. So what do we need to use to find that out? Well, here's our choices. Photo gates placed at the beginning, end, and at various locations along the track the car travels on. A meter stick to measure the distance of the track that the car travels on. A motion detector oriented perpendicular to the direction that the car travels. A mass balance to determine the mass of the car. So, if you want to know speed, the variables that affect speed are distance over time. And the difference between average speed and instantaneous speed are the intervals over which you're measuring. So if you have a distance like this, So if you take this whole distance and divide it by the whole time, you have an average velocity. If you can narrow that interval down to a smaller one, then you've got an instantaneous velocity. A photogate will enable you to do that. So you can use that. And another thing you can do is you can measure them, use a meter stick, right? So that you know how big these intervals are that you're measuring using the photogate for. The problem with this is that if the car is traveling, if there's a top view, the car is traveling this way. If the motion detector is here, well, it's only going to see this one spot. So this isn't going to work so well. A mass balance determines the mass of the car. Mass has nothing to do with it. It's not going to help you at all to find a speed.